Okay, let's talk about chemical properties of elements in the same group. Alright, so let's take a look at group 1. These are the alkali metals. They are very reactive. They increase in reactivity going down the group. Okay. Remember that metals react by giving up an electron. Okay, so the larger the atomic radius, the less energy required to remove an electron. Let's get that right, sorry. Less energy required to remove it. Okay, so that's really a lower activation energy, can be seen as, right, more reactive. Hopefully that makes sense. Okay, so the alkali metals react with water to form the hydroxide and the hydrogen gas, and then you would have to balance these out. Okay. If there's enough energy released, you can actually get that to light on fire. Right? They also react with the halogens to form, by the way, that's a gas, sorry, to form the soluble chloride salts. It would be a solid unless I put it in gas. Okay, so let's take a look at group 7. These are the halogens. And they are really going to react by gaining an electron. So their reactivity increases going up the group, because the smaller radius is able to attract the electron. Larger radius, which would be down at the bottom of the group, is going to have a harder time attracting that electron. So chlorine would be more reactive than bromine and would cause this reaction to occur. Okay, the opposite would not happen. There's a test that you can test for the presence of halide ions. Basically, you are going to react it with a silver solution, typically silver nitrate. The silver chlorides are colored, and they are precipitates. This is white. Silver chloride is white. Silver bromide is cream. And then silver iodide is a yellow. Okay, and you can use that as a test to find them. All right, if we look at the change in metallic behavior, okay, across period 3, okay, it changes from metallic to non-metallic characteristics going across group 3. You have sodium, magnesium, and aluminum being shiny and conductive. Then you have silicon, which is a semiconductor and a metalloid, has properties of both metals and nonmetals. And then you have the phosphorus, sulfur, chlorine, and neon, which are non-conductive. Okay, and nonmetals, so non-metallic properties. Metal oxides tend to be basic. And I meant to stop that at the magnesium. Nonmetals are acidic. The oxides of these are acidic. Aluminum is amphoteric. It can react with both acids and bases. And then the silicon the silicon oxide does not react with water, but it will react with a base. It is considered a weak acid because of that. Okay, weak. So it's a weak acid. Okay, let's just do this on another. Here's another one. Okay, so the silicon oxide will react with sodium hydroxide to form sodium silicate and water. That's NaSiO2. Alright, so it is considered a weak acid, but it does not react with water. And then the aluminum oxide will react with hydrochloric acid. 6 of these. This is a solid. This is aqueous. Goes to aluminum chloride and water. Then when it reacts as a base, that's when it reacts as a base. This is when it reacts as an acid. Oh, excuse me. +3 waters. Sorry about that. It goes to make this sodium aluminate. Sulfur dioxide reacts with water. This is a gas. Oh dear. Goes to make sulfurous acid. SO3 goes to make sulfuric. Then we have P4O10 with water to make phosphoric. And then we have dichloro heptaoxide with water, going to make perchloric acid. Alright, the next thing I'm going to draw is kind of a summary. And I might draw it and then come back because I'm already close to 10 minutes. Alright, so here's a table. It looks pretty big. Yep. So, basically, we're looking at the formulas. I'm hoping that you can come up with these formulas. One that you may not be familiar with is going to be that phosphorus oxide. You have sulfur trioxide and then the Cl2O7 or Cl2O. You can see the states go from solid, solid, solid. Phosphorus oxides are solids. The sulfurs go from a liquid to a gas. And then the chloride oxides, liquid to gas as well. Melting points kind of peak at the magnesium oxide, which makes sense because of the increased charge, +2 plus -2. The aluminum and the oxide are probably getting larger, which kind of decreases that melting point a little bit. You have a giant covalent compound here, and then the melting points kind of coinciding with the liquid and the gas as well. Boiling points, same kind of thing. Conductivity in the molten state. Hopefully you realize the ionic compounds are going to be conductive. The giant molecular compound is going to be a poor conductor, and then your non-metal, those simple covalents, are not going to be conductive. Ionic, giant covalent for the silicon dioxide, and then simple covalent for the others. We did kind of already do the reactions with water. Interestingly, that the aluminum oxide and the silicon oxide are said to not react with water. Alright, next thing we'll talk about is going to be the fluoride, the third period. That'll be the next screencast.